Hello everyone, welcome back on mahasarkar.co.in. In previous video, we have learned about the differential equation of linear simple harmonic motion. Now, using that differential equation of linear simple harmonic motion, we are going to derive acceleration, velocity and displacement of particle. Before that, let me write the differential equation of SHM is given by d square x upon dt square plus omega square x equal to 0, where x is what? Displacement of particle and omega is angular frequency. Okay. Now, considering this equation as the base, we are going to find out first acceleration, then using acceleration we are going to find out velocity, and then we are going to find out displacement. So let's find out first acceleration in SHM, so indicated by small a. Now if you remember, we have learned in a previous article also that if x is the displacement of the particle, if x is what? Displacement of particle, then velocity v can be written as what? Dx upon dt, and acceleration a can be written as what? D square x upon dt square. So say this is equation number a. So using equation a, what we'll get? See, d square x upon dt square plus omega square x equal to 0. Shift this plus this side, so we will get d square x upon dt square equal to what? Minus omega square x. As you can see, d square x upon dt square is nothing but what? Acceleration. So finally this value on LHS, that is acceleration in SHM, can be obtained as minus omega square x. This equation gives the acceleration of particles performing the linear simple harmonic motion. Now, using the basics of acceleration, we are going to find out the velocity. So, velocity of particle in a simple harmonic motion. We have acceleration equal to, acceleration a is equals to what? Minus omega square x. But what is acceleration? Dx upon dt. So I will replace this acceleration. It is like what? Dx upon dt equal to minus omega square x. I will just adjust the term. If you have gone through the mathematics using chain rule, then I am adjusting the chain rule. I am writing like dx upon dv into dv upon dt. dv will get cancelled. It will be what? Dx upon dt equal to what? Minus omega square x. Now here, this term, if I write in a different pattern, few corrections. Acceleration we can write what? Dv upon dt equal to minus omega square x. I initially wrote it is wrong. So if I now adjust this, it is like dx upon dt into dv upon dx. So I have adjusted dx here, not dv. Okay. So equal to what? Minus omega square x. But as you can see, dx upon dt is nothing but what? Velocity. So I can say v into dv upon dx is equals to minus omega square x. I'll shift this dx, so v into dv equal to minus omega square x into dx. Now it is the formula, or it is the method of separation of variables in the differential equation that you have learned in the mathematics. So to obtain the actual terms, actual function, we have to integrate this. So on integrating, what we will get? On integrating, we shall get integral of v dv equal to integral of minus omega square x into dx. Minus omega square is constant, omega square x into dx. What is the law of integration of x raised to n? Integration of x raised to n dx is equals to x raised to n plus 1 upon n plus 1. So using this, if I apply this formula, so here power is 1, so here should be v. Power is 1, so integral can be v square by 2 equal to minus omega square. Its integral can be what? X square by 2 plus c, where c is constant of integration. Okay, these are some basic mathematical steps that you are well familiar with them. Now, if I consider particle is performing simple harmonic motion and particle reach to extreme position. When particle will reach to extreme position, its displacement will be maximum. Okay, what will be the velocity? It has to travel from mean position to extreme position. Until and unless it stops at the extreme position, it will not come back. In other words, if I consider the position of particle at extreme position. Therefore, I will say x equal to plus or minus a, where a is an amplitude and v equal to what? 0. So if I substitute this value in, say, this is equation number 2, where this will be the equation number 1. So what will get equation number 2? I will get v square upon 2 equal to minus omega square. Value of x will be now a. So it will be like a square upon 2 plus c. Sorry, this v is 0, so it will be 0 square. So finally it is 0 equal to minus omega square into a square upon 2 plus c. Therefore, I will get c equal to omega square a square upon 2. Say this is equation number 3. Put value of 3 in 2 again. Then what will get? Therefore, equation 2 becomes v square upon 2 equal to minus omega square x square upon 2 plus value of c is omega square a square upon 2. Okay. See this plus term and this minus term, I am writing this term ahead and taking omega square by 2 common, which is like a square minus x square in bracket, this side v square by 2. So what is v square equal to? 2 get cancelled. It is v square into a square minus x square. Taking square root on both sides, what we are going to get? V equal to plus or minus omega in root a square minus x square. This is the expression for velocity of particle performing linear simple harmonic motion. If where a is the displacement of the maximum displacement, here a is maximum displacement and we call it as what? Amplitude of SHM. Okay. Now using this velocity, we are going to find out that last term, that is displacement. Now, third term that we are going to find is what? Displacement of particle in the SHM. To find the displacement, we will use velocity. We have velocity v equal to plus minus omega. If I write in magnitude only, then I will get only omega in root a square minus x square. Okay. But what is v? Then v is what? Dx upon dt. Therefore, it is what? Dx upon dt equal to omega in root a square minus x square. What I am doing is simply, this term contains x, so I will shift it to the LHS and this term to the RHS. So it will be like dx upon root of a square minus x square equal to omega into dt. Now this is again, variables are separated on both sides, so I am again on integrating, what will get? Integral of dx upon root of a square minus x square into equal to omega in integral 1 into dt. Into dt means only 1 into dt. So this is the standard formula. You should remember the formula for integration. This is the standard formula for integration of sine inverse x upon a equal to omega. Integration of t 1 with respect to dt will be t, and the constant of integration is say here is alpha. So if I rearrange these terms, I will get x upon a is equals to sine of omega t plus alpha. So using this, I will get x equal to a into sine omega t plus alpha. Here we should not get confused. Here this a is used as amplitude. So I have made this mistake here again. It should be capital A. So we should not get confused between acceleration a and amplitude a. So this will be a. So this is the equation of displacement of particle performing linear simple harmonic motion. Now there are some important cases using which one can find out the values of maximum and minimum displacement. So maximum values of displacement, maximum and minimum values. Maximum and minimum. I will make small table. First I will write acceleration, then I will write velocity, and finally I am going to write displacement. Okay, mean position and extreme position. Now let's discuss. Here only I am writing in short. If particle is at mean position, then x is 0. If x is 0, this will also 0. So at mean position, acceleration is what? 0. At extreme position, distance will be what? Plus or minus a. So at mean position, x equal to what? Plus or minus a. Therefore, acceleration a equal to minus omega square a, plus or minus. Okay. So this is maximum value of acceleration. This will be what? Minimum value of acceleration. Now for velocity. Say at mean position. So if at mean position x is 0, if x is 0, then it will be like v equal to only omega in root a square. It will be a into omega. This is now maximum acceleration. But if I put x equal to a, when is particle at extreme position, x equal to a. So a square minus a square will be what? 0. So v equal to omega in root 0. That will be what? 0. So it will be minimum. See, at extreme position acceleration is maximum but velocity is minimum. Like same displacement. So for displacement, if particle is at mean position, displacement is 0. And if particle is at extreme position, displacement will be plus or minus a. These things we are going to keep in mind. This is though completely mathematical article, but all the important terms are involved here to explain the acceleration, velocity and the displacement of the particle performing linear SHM. I hope you understood this article. Thanks for watching mahasarkar.co.in. Have a nice day. And you can take a screenshot to write the notes.